as I discussed in the last problem, the load on a bolt consists of an axial pull of 10 kilonewton together with a transverse shear force of 5 kilonewton. Find the diameter of bolt required according to maximum principal stress theory, maximum shear stress theory, maximum principal strain theory, maximum strain energy theory, and maximum distortion energy theory. In the last class, we have concluded that, right, due to two loads, two stresses are induced in the component. First one is due to pull, we have tensile stress. Due to the transverse shear force, we have shear stress. And the tensile stress will be calculated by using the formula load by cross section area of the bolt, and second one, the shear stress, is calculated by the formula shear load by cross section area of bolt. So the cross section area is not given in the problem, so that cross section area should be with respect to diameter. That's what we need to calculate. So let us go for the solution. First, you write down whatever may be the data given for you. Write the data given for you. So first, the given data. The tangential, that is axial pull, is given as 10 kilonewton, which is taken as PT equals to 10 kilonewton. Transverse shear load is 5 kilonewton, and the stress is 100 megapascals, and Poisson's ratio is 0.3. So as we want to calculate the diameter of the bolt, so let us take D is diameter of the bolt. So corresponding to that diameter of the bolt, the cross section area is equal to pi by 4 d square. That is the area of a bolt. So by simplifying that, we are getting 0.7854 d square. This is the cross section area of the bolt. Now I am calculating the stresses. First one is axial tensile stress. This axial tensile stress is due to axial pull of 10 kilonewton. So axial tensile stress equals to load by area. Load is given as 10 kilonewton, converted into newton is 10,000 newton, and area which we have calculated is 0.7854 d square. Substitute the values, and by simplifying that, we are getting the axial tensile stress as 12,730 by d square megapascal. Okay, now we are going for the second step. We are calculating the shear stress. Tau is equals to shear load by area. Shear load is given as 5 kilonewton, that is 5,000 newton divided by cross section area. So we are getting the shear stress as 6365 by d square megapascal, 6365 by d square megapascal. So now we have two loads. Two loads are giving us two stresses. So we have calculated the induced stresses due to axial pull as well as transverse shear load. One is tensile stress is 12,730 by d square megapascal. Second one is direct shear stress is 6,365 by d square megapascal. These are the individual stresses which are induced due to the load applied on that particular bolt. So as we know that already we have discussed, there we have three stages in the solution whenever they have given the loads. First stage is calculating individual stresses. Second stage is calculating principal stresses. Third stage is applying theories of failure in order to get the dimensions of a given machine member. So we have finished the first step, that is nothing but we have calculated the individual stresses induced due to application of the loads. Now I am going for the stage number 2, that is calculating principal stresses. So first one is maximum principal stress. Here I have taken the formula which we have already derived. When a machine member is subjected to two tensile stresses and one shear stress, the maximum principal stress is sigma 1 plus sigma 2 by 2 plus root of sigma 1 minus sigma 2 by 2 whole square plus tau square. This is the formula which we have derived. Now here I don't have two tensile stresses. So sigma 1 is sigma t, sigma 2 is 0 and tau is available. So we are making sigma 2 as 0 in this equation because we don't have second tensile stress. Right, that is the equation which we have derived by considering that we have two tensile stresses and one shear stress. Here in this particular case, as the bolt is not subjected to second type of tensile stress, so sigma 2 becomes 0. So now the equation becomes sigma 1 is 12,730 by d square. So sigma 1 by 2, that is 12,730 by d square by 2. Already 2 is available for us, plus sigma 1 minus sigma 2. Sigma 2 becomes 0. So sigma 1 is 12,730 by d square and 2 remains there. Whole square plus tau. Tau is 6,365 by d square whole square. Now we have substituted the values in the equation, and by substituting these values in the equation and simplifying, we are getting 15,365 by d square megapascal or Newton per mm square. This is maximum principal stress. Then similarly, we are going to calculate minimum principal stress. What will be the formula for minimum principal stress? Simply here, in place of plus, we can have the minus. Now you calculate minimum principal stress. Minimum principal stress is sigma 1 plus sigma 2 by 2 minus root of sigma 1 minus sigma 2 by 2 whole square plus tau square. Only the change is here, in place of plus, we are getting minus. ఆ పుస్తకాల కల నేను వచ్చి పెడతాను క్లాస్ స్టార్ట్ అయిపోయాడు కనుక్కోండి. వాళ్ళు ఖాళీ ఉన్నాడు ఒక 10 నిమిషాలు వినండి. So we are getting minimum principal stress. Sigma T2 is equal to sigma 1 plus sigma 2 by 2 minus this. So in this equation also sigma 2 becomes 0. So by substituting the values, we are getting minimum principal stress as minus 2636.5 by d square. You have already solved, you might be solved that one. You just verify your answer. Then third one, we are calculating maximum shear stress. That maximum shear stress is calculated in two ways. One way is it is algebraic difference of major and minor principal stress. That is nothing but sigma T1 minus sigma T2 by 2, or else straight away we can take sigma 1 minus sigma 2 by 2 whole square plus tau square total under root. This is the equation. Maximum shear stress equals to sigma T1 minus sigma T2 by 2. Sigma T1 value is known, sigma T2 value is known. So by substituting those values, you can get the answer, or else you can have this equation, that is sigma 1 minus sigma 2 by 2 whole square plus tau square. Now substitute the sigma 1 and tau value, you can get the answer. Both are same. Either you use these two values in order to calculate maximum shear stress, or use this equation. Both are similar only. So from that we are getting the equation as 9000 by d square megapascal. So stage number 1 is calculating individual stresses, and stage number 2 is calculating principal stresses. We have completed two stages. So first we have calculated the individual stresses which are included due to application of the load, and second one, as the bolt is subjected to two different stresses, we need to calculate the principal stresses. Those are maximum principal stress, minimum principal stress, and maximum shear stress. So we have calculated principal stresses. Now we are going to use equations of theories of failures. So let us go for different equations. And we are assuming, as the factor of safety is not given in this particular problem, we are assuming factor of safety as 1. Now we are going for the first theory of failure, that is maximum principal stress theory. Maximum principal stress theory equals to sigma T1 by sigma T1 equals to sigma Y by Fs. Sigma T1 equals to sigma Y by Fs. So that sigma T1 already we have calculated, and sigma Y is given, Fs is assumed. So you just substitute the values in this equation. Sigma T1 is 15,365 by d square is equals to 100 by 1. So by simplifying that particular one, we are getting d is equals to 12.4 mm. First one, maximum principal stress theory, which is also called as Rankin's theory, in which the major criteria is maximum principal stress. So we are using the equation of maximum principal stress theory, that is sigma T1 is what it is, sigma T1 is equal to sigma Y by Fs. Fs is factor of safety, sigma Y is yield stress, and sigma T1 is maximum principal stress. So substitute all these values in the equation. So we are having only one unknown, that is nothing but d. So from this equation we can get d, the value of diameter of bolt is 12.4 mm. Now we are going for the second theory, maximum shear stress theory. So the criteria of theory is maximum shear stress. So as per this theory, tau max is equal to tau y by Fs. Maximum shear stress. This is the induced shear stress, and tau y by Fs is allowable shear stress, which is nothing but property of the material, which is calculated from laboratory test. Right. So tau max is equal to tau y by Fs. As tau y value is not given in the problem, we know the relationship tau y is equal to sigma y by 2. The strength in shear is 50% of strength in yield. So tau y is equal to sigma y by 2. So by substituting that, tau max is equal to sigma y by 2 into factor of safety. So tau max is already known, 9000 by d square is equal to sigma y by 2 fs. Sigma y is 100 divided by 2 into factor of safety is 1. Substitute the values, you can have the second value for diameter of the bolt, or the value of diameter of the bolt according to maximum shear stress theory or guessed theory, that is D is equal to 13.42. You do the calculations once again, right? Don't just note it down from the slide. Here I did the calculations, right? Maybe or may not be they are correct or not. You just do the calculations by using your calculator. Take your pen, paper, calculator, everything. So second theory is completed. Third one, maximum principal strain theory. In this maximum principal strain theory, the major parameter is principal strain. So here induced strain will be just compared with allowable strain to say whether the component is failed or not. So certainly the induced strain should be less than or equal to allowable strain of the material. So the worst situation to avoid the failure is induced strain is equals to allowable strain. So there the equation is sigma T1 by E minus sigma T2 by E. That is induced strain, which is equals to allowable strain is sigma Y by Fs is allowable stress, which is divided with Young's modulus to get the allowable strain. So E the common factor in all the three terms. So it got cancelled. The ultimate equation is sigma T1 minus sigma T2 is equals to sigma Y by Fs. I think some term is missed. What is the term missed here? Is anybody, is any term is missed here? If this equation is correct.
Sir, by 2, no.
Hmm? Is any term is missed?
Young's modulus.
Young's modulus is available. One term is missed. Just is anybody in position to identify it? Poisson's ratio is missed. Poisson's ratio. Sigma T1 by E minus sigma T2 by ME. That is the Poisson's ratio. Is it or not? One is the longitudinal strain, one is the lateral strain. So lateral strain should be converted into longitudinal strain by using Poisson's ratio. So here Poisson's ratio is missed. Poisson's ratio is indicated either by, what is the equation? Here simply we can have M. This is the modification. We have missed Poisson's ratio. Sigma T1 by E minus sigma T2 by ME equals to sigma Y by E into Fs. So which is nothing but sigma T1 minus sigma T2 by M equals to sigma Y by Fs. So you check this answer, whether I have included 0.3 or not. You just check this one. You check and confirm it. Is it 12.7 or something else? Okay, this is the third one. So we are going for the fourth one, which is nothing but maximum strain energy heat. Sigma T1 square plus sigma T2 square minus 2 sigma T1 sigma T2 by M, which is equal to sigma Y by Fs whole square. This is as per fourth theory, maximum strain energy theory. So simply we are substituting the values sigma T1, sigma T2 values as well as sigma Y. Substitute the values and simplify it. You can get the diameter of bolt. So diameter becomes some 12.78 mm. You have to do all the calculations. So fifth theory is maximum distortion energy theory. As per this, sigma T1 square plus sigma T2 square minus sigma T1 sigma T2 is equal to sigma Y by Fs whole square. So here the principal parameter which we are just using for comparison is distortion energy. Substitute the values and simplify it. You can have diameter as 13.4, so this is the complete solution of given problem. They have given loads. From the loads we have calculated individual stresses. From individual stresses calculated principal stresses, then taken the equations of theories of failure to get that particular unknown D. So we got the diameter of the bolt as per all the theories of failures. This problem also came in the earlier examinations. Okay, if you understood a single problem, that's sufficient, because almost all the problems will be in similar manner only. In some of the cases, something will be missing. In some cases, they will give what it is, principal stresses we have to design. In some cases, they will give us only stress directly, and we have to design a problem depending upon the situation. Here we went for the complete solution from the load to theories of failure, right? If they have given the stresses, there is no need to calculate the stresses once again. If they have given principal stresses, there is no need to go for principal stresses. Straight away we can use the equations of theories of failure. Okay, so next two problems are similar. Now you just note down the problem and try to solve it. We have to solve the remaining two problems. You have to solve the remaining two problems within half an hour. First one, a cylindrical shaft made of steel of yield strength 700 megapascal is subjected to static loads consisting of bending moment 10 kilonewton meter and torsional moment 30 kilonewton meter. Determine the diameter of the shaft using two different theories of failure and assume a factor of safety of 2. Take E equals to 210 gigapascal and Poisson's ratio as 0.25. Steel cannot be having this strength. You just make it modify as 210 megapascals. 210 mega or giga. 2.1 into 10 power 5. Now you start your solution. This is the problem given for you. You go for the solution. The things you should identify is, here already types of loads are given. One is bending moment. So due to bending moment, what is the stress induced? Bending stress. You know the formula for bending stress. Due to torsional moment, we have shear stress. So our first job is calculating individual stresses. One is bending stress, other one is shear stress. That is stage number 1. Stage number 2. From these two, you calculate principal stresses. sigma T1, sigma T2 tau max. Then stage number 3, by using any two theories of failure, you calculate diameter of the shaft. Start your solution. All the So whoever finished the solution, you can go for answers here. So the data given for you is sigma y is given as 700 megapascal, Poisson's ratio 0.25, bending moment 10 kilonewton meter, torque 30 kilonewton meter, Young's modulus 210 gigapascal, factor of safety is 2. So first we are calculating bending stress. Oh. Bending stress is equal to maximum bending moment by section modulus for a circular shaft. The section modulus is 5d cube by 32. So by substituting those values, it becomes 32 m by 5d cube. M is moment already given here, 10 kilonewton meter, should be converted into Newton millimeter. 1 kilonewton equals to 1000 millimeter, 1 kilonewton equals to 1000 Newton, and 1 meter equals to 1000 millimeter. So here 32 into M is 10 into 10 power 6. Here the bending moment is given in kilonewton meter, converted into Newton millimeter. So 32 into 10 into 10 power 6 by pi d cube, which becomes 101.8 into 10 power 6 by d cube megapascal. Then we are calculating the shear stress. Shear stress is calculated by using the shear stress equation T by J equals to tau by R. T by J equals to tau by R. So the tau is equal to 16T by pi d cube. Substitute all the values in the equation, and by simplifying it, you can have the equation tau equals to 16T by pi d cube. So 16 into T is given as 30 kilonewton meter converted into Newton millimeter, right? And by simplifying it, it is 152.8 into 10 power 6 by d cube megapascal. So initially we have calculated individual stresses. And in stage number 2, we are going for the principal stresses, maximum principal stress. So sigma T1 equals to sigma 1 plus sigma 2 by 2 plus root of sigma 1 minus sigma 2 by 2 whole square plus tau square. Again here, sigma 1 equals to sigma b, and tau is equals to tau, sigma 2 is 0. So we are substituting those values in the equation. You can have maximum principal stress, minimum principal stress, and maximum shear stress. Whoever solved it already, you can verify the answers, or else you can note down. అన్ని కరెక్షన్స్ వస్తాయి ప్రతి స్క్రిప్ట్ లో అన్ని వస్తాయి మనకి టైం చేస్తారు అవార్డు లిస్ట్ మా ఎంటర్ చేస్తున్నారు కొత్త అవార్డు లిస్ట్ చేస్తారు అదే స్క్రిప్ట్ వచ్చేస్తాయి ఓకే తర్వాత సైన్ చేస్తారు Please mute your phones. Okay, you can go for any two theories of failures. Here I have taken two. One is maximum shear stress theory. Second one is maximum strain energy theory. You can go for your any two theories of failure. There is no restriction because in the problem the liberty is given to you. Okay, you can go for any two theories of failure. Here I have taken these two only. I'm giving this much of time to solve the problem by you. Okay, don't sit ideally. This is problem number 12. Then we are going for problem number 3. Problem number 13, 3 under this category. A mild steel shaft of 50 diameter. So here the machine member is shaft and its dimension is already given for us. Is subjected to a bending moment of 2000 Newton meter and a torque. Here they are not given the value of torque. Okay. If the yield point of the steel in tension is 200 megapascal, find the maximum value of this torque without causing yielding of the shaft according to maximum principal stress, maximum shear stress, and maximum distortion strain energy theory. So this is the problem where they are given unknown torque. Due to this bending moment and torque, we are having the diameter of steel shaft as 50 mm. Right, they have given the dimension of steel shaft. Now what will be the torque you have to apply to avoid the failure as per these three theories. As usual, same thing. What it is? First, we need to calculate bending stress by using bending moment equation. Then you calculate the shear stress in terms of T itself, right? Then you go for remaining. So we are calculating initially the bending stress. Bending stress equals to m by z, that is 32 m by pi d cube. Already d is given. Right. We are assuming the torque, maximum torque without causing yielding of the shaft is in Newton millimeters. Okay. So we got bending stress as 163 megapascal. Then we are calculating shear stress in terms of torque itself, 16T by pi d cube. So by simplifying it, it is 0.0407 into 10 power minus 3 T megapascal. As usual, we have calculated individual stresses. One is bending stress, other one is shear stress. Then stage number 2, you calculate maximum principal stress, minimum principal stress, and maximum shear stress. Everything in terms of T itself, because T is unknown in this particular problem. Sigma T1, sigma T2, and tau max. Here also we don't have second stress, that's why sigma 2 becomes 0. So 163 by 2, by simplifying it, it becomes 81.5. 81.5 plus 81.5 whole square plus 0.0407 into 10 power minus 3 T by D cube whole square. Yeah, here we have another mistake. Already D is given. Here what it becomes? Only it is tau square. So 0.0407 into 10 power minus 3 T whole square. That's it. Already we have substituted D value as 50. So by substituting that value, we got this 0.0407 into 10 power minus 3. So this is stage number 1. This is stage number 2. Then third stage is they ask you to calculate torque as per maximum principal stress theory. So sigma T1 equals to sigma Y by Fs. Already sigma T1 is calculated here. 163 by 2 plus root of this equals to S. Here also it is. Okay. 163 by 2 plus root of 163 by 2 whole square plus 0.0407 into 10 power minus 3t whole square, which is equals to 200 by 1. One equation with one unknown, easily you can solve. So T becomes 2118 into 10 cube Newton millimeter. Similarly, they ask you to calculate the torque as per maximum shear stress theory. That is tau max is equal to tau y by Fs, which is equal to sigma y by 2 into Fs. So here T is unknown, we can calculate the torque. T is equal to 1426. So third theory is maximum distortion energy theory. Sigma T1 square plus sigma T2 square minus sigma T1 sigma T2 equals to sigma y by Fs whole square. Substitute the value of sigma T1, sigma T2 minus sigma T1 into sigma T2 is equals to 200 by 1 whole square. So by simplifying it, the torque becomes 1647 into 10 cube Newton millimeter.